All right, it's going to be polymer based. And so you're going to have like the reactions that can do this, all right, are either going to be those the AABB ones, the AB type polymer, or all right, so that was your step growth, bless you, or your chain growth. So those are your options. And in the chain growth, you had radical, you had well, I did anionic first, anionic polymerization, and then cationic polymerization. Okay. So your direction for this problem will be propose polymer structures for the following reactions. Okay. And you have your notes again for this final, for this exam, not for your final. Your final, I'll give you notes. Okay, I have more, but I can't fit more on the screen, so work on those three. We'll go through them. All right, so this is probably going to be around like a 25, all right, to 30-point problem, because I'm going to give you like 5 or 6 of them, all right? And you always get credit for putting something in the box. Yes.
It says you were signed out because you signed into another device.
Oh. All right. This first one. So you should realize, okay, that there's two products here by disproportionation. That's where you have that abstraction of a hydrogen. In this case, all right. Okay, if you put hydrogen, fine, but deuterium would be okay as well, right? So just to show you what, all right, it's the AIBN is the initiator, and I told you you don't have to know the structure of that. So the radical that you would have oh, sorry, let me just turn this on. Okay. All right, so that's your radical that you're working with. Okay. So that when you abstract the hydrogen, so one product that I showed you had a double bond in it. And so there you're abstracting a hydrogen. And you'll get that product. Let me fix my double bond. My methyl group, I mean. In the other product, you will just simply protonate that radical. If you put hydrogens here and here, that would be okay. All right, I would accept that. The trick is this part here is understanding this. Do we understand how that this is the repeating monomer? Gabriella.
I'm sure Linda understands how you even got the radical.
Okay, all right. So let me scroll. Okay, so when we did this reaction, right? You had your initiator that formed a radical. Let me actually put the initiator on the other side just so that. All right, there's my initiator. Those are going to come together and then I'm going to get a radical. So initiator, deuterium, deuterium, radical. Do you see that?
Yeah.
Okay. All right. And then we have our propagation steps. So this is, all right. So just to be clear, so actually, so we're in chain growth at this point when the initiator is reacting. All right, so that would be like the step 2. All right, remember initiator was as you form the initiator radical. All right, so now we're in the chain growth phase. All right, so you see how I got that? All right, so what this links ends up being linked is that's what I started with. Okay, when you do the hydrogen abstraction, all right, so we have deuterium present. So 2 things can happen here. So this radical, I kind of showed it like self happening, but essentially, if you have more monomer, do it like this. All right. No. So essentially, this radical here can combine, and then these electrons can go there, and you can get another deuterium radical. So with that first product where I had the double bond, I just didn't show the deuterium radical. Okay. So that was the first product with the double bond. If you have product that forms like this, right, and you make this deuterium radical, that second product can come from more of our, our chain growth radical. And that combining. So that's where those two products come from, right? We did a second type of product when we did radical reactions. Does anyone remember what that one was called? So that's where these two disproportionation products come from that I drew above. Does that make a little bit more sense?
Yeah.
All right. So the other type of product that you can get can come from radical coupling. So that would be two of these coming together. Right. Do we see how those would link together? So that's two of these reacting here at this position. Reacting end to end. Right, so those are the two types of products that you get from a radical reaction. Is that a little bit clearer, Grace? There's three, yes, but I told you, I'll tell you what type of product I want you to draw, either from radical coupling or disproportionation when you have the radical reaction.
And then with just for
Mhm.
is there ever gonna be where we have, like, in my notes, I have construction for hydrogen there?
I'm pretty sure, did I not write the double bond down?
I don't have it on my notes.
Okay, sorry, I have it in my notes here, so I guess I didn't write it down. All right, so then let's do this. Then for disproportionation, then I want you to focus on just this product where you add the hydrogen to the radical. Okay. So one product for each, right? And we can ignore the double bond one. Do we have any other questions with this reaction? All right. The second one here. Okay. This is the cationic polymerization, right? This is an electron donating group. So you get a hydrogen on the end. So this is your repeating unit. And when you add water, you get your OH. Okay. Does everybody see that one? So again, so the radical that you would, well, so this one is not a radical, it's a cation. Right? I'm gonna just scroll down so that we could see it. So you have that H. BF4. You have your monomer. Your pi electrons. Take your hydrogen. You get your cation. Your pi electrons go after the cation. You make a new cation. So that is your chain. Right. And then you terminate by adding water. Did everybody see that? Okay. All right. Then, all right, we have anionic polymerization. You have that butyl lithium group. So that is going to be our end group. So 1, 2, 3, 4. Our repeating unit. So the repeating unit. About to make sure. There we go. Okay, so 1, 2, 3, 4. Then this is your repeating unit. And you added carbon dioxide. Okay. So the end is going to have a carboxylic acid. Do we have any questions with this one? Do you want me to go through the like just the step stuff again? All right. Okay, so the first step of this process is reaction with that organolithium. So 1, 2, 3, 4. All right, so this is a negative carbon. So we're going to get a carbanion. Then we can react with more monomer. So that our chain grows. And we have our repeating subunit. This anion is a nucleophile that when we add carbon dioxide, you have that, and then that last step, we protonate. And we have our intact polymer. Do we see that? Okay. The other way that you could cap this reaction was with an epoxide. Right, and that's where we would open up the epoxide, because again, you have a nucleophile.
It's
Yeah.
an extra carbon.
In my other one?
Yeah.
Oh, come on. Okay. All right, do we have any questions with those? So that's just, so those are the 3 chain growth, right? So then we had the step growth ones that we looked at. So let's just do some examples of those. All right. So this is again, that same problem where I'm going to give you reagents, you have to fill in the box with the polymer. The D and E are that AA, BB, and F is that AB. All right, so for this first one, it's a polyamide. So also too, if you think about this whole A, B, B, so what that means is on the end, you have to have one A, and then in the middle, you're showing A, B linked, and then on the other end, you're showing the B. Okay, so. Here's my A end. There's my A, B. And then there's my B. And that repeats. Does that help? Do we see that?
Why did they do the methyl group instead of NH2?
It's not a methyl group. Sorry. I didn't add the extra parentheses. It is a carbon. It's not a methyl. Okay. All right. So then the next one. This one's a little bit trickier because you're just dealing with, there's no chain here. Just the one atom, okay? So that here, you're gonna have it's not like this one's a little bit harder. It's not that as clear of an A, B, B, just because there's no chain. It's just the carbonyl. Oh, let me put my N there. All right. The last one, you have to realize you're going to open up this. Okay, so this catalyst is going to hydrolyze the ester. When you hydrolyze an ester on one end, actually, sorry. Right. On one end, we are going to have this negative, well, it'll actually be an OH, okay? On the other end, you're going to have a carboxylate. So here's my A and here's my B. Okay. So that when you protonate at the end, okay, your repeating unit essentially is going to be a polyester. Okay, here's my A, here's my B. That last step caps the hydrogen on that OH group and the carboxylate oxygen. Okay. So this is a polyester. Because you have both reactive, you have an A and a B on the same molecule. It's not like we're adding an AA molecule and a BB molecule. Do we see the difference between? Okay, D, E, and F. You can make a polyester because you're going to have an OH on one side and a carboxylic acid on the other. So you can self-react. A and B are on the same molecule. Whereas with D and E, all right, it was the amine can only react with the esters. So it's that A reactive unit on one molecule and the B reactive unit on the other molecule. Okay. All right, so that's one problem, right? So you have 3 types of chain growth reactions that you need to know. And then you have these step growth ones. All right. Yeah.
I'm kind of confused on for F, like, how we know where to put F.
Okay, so it has to be a polyester. All right. So one unit has to come. So if you look at what we did above, right? You have one piece coming from one molecule, then you have the ester link, the amide linkage, and then you have the carbonyl. Because then over here, it would be an N, and over here it would be a carbonyl. Okay, so here, all right, the repeating linkage is going to essentially look like this because the chain I forgot it now. That's your repeating unit, right? That's what the polymer part looks like. So this is the repeating unit. Okay, and then you just cap the ends to stop the growth once all the monomers are consumed. Does that make a little bit more sense now when you see it? Okay. So if it helps you, draw it out. Like draw a couple, like what I was doing up here, right? I drew a couple of them out so that you could see what it looked like. I'm assuming once I did that, it made my answers a little bit more clear. So just take the time, draw like a couple of the monomers linked together so that you could see what it looks like. And then you could figure out, okay, that's my repeating unit. That's what I'm putting in parentheses. Pamela.
For E, those hydrogens on the oxygen will just be more.
Yeah, because it's an alcohol reacting with an acid chloride to make the ester. That was one of the carboxylic acid derivative reactions. Okay. The oxygen itself will, so this one's a little bit different because again, there's the carbonyl reacts both ways. So do you see that? So that's why the repeating unit is that. Because the carbon, there's no chain for the carbonyl to react with, right? It's the anchor point for both sides. All right. All right, so then I told you you're going to have some kind of like identification as far as your carbohydrates go, as far as your lipids and your amino acids go. All right, so. Oh, come on. Sorry, there was a linkage here that I. All right, which one's the reducing sugar? A or B? Yep. You have a free hemiacetal. There's no, oops, sorry, I had no line. All right, there's no hemiacetal here. Okay. All right. Sorry, we still copying. All right. All right, which of the following compounds is a saturated triglyceride, A, B, or C? It's B. Mhm. What is A? Good. And what is C? Yep, phospholipid. Good. So draw the predominant, draw the predominant form of proline at pH 7.4. Oh, sorry, I gotta add the extra hydrogen. Sorry. So this is the one that has the pK of 10.6. All right, so we should know that at pH 7.4, the carboxylic acid will be deprotonated, the nitrogen will be protonated. Does everybody see that? Grace?
This is kind of off topic. Are you gonna post the key to last week's presentation?
Sure, I can get that done. Okay. All right, let's do another one. They added an extra. Me sorry, I added an extra card in. All right. So. How many amino acids are there? Label the N and the C termini. And then label the non-polar, the polar, the acidic, and the basic amino acids. All right, so the N terminus is where you have that protonated amino group. C terminus is where you have the deprotonated carboxylic acid. There is one. Here's two. Here's three. And here's four amino acids. AJ.
It's always naturally N to C, correct? Am I right?
Yeah.
Okay, so it's three of each N to C.
Yeah. Non-polar. Polar. Acidic. Basic. Because of this amino group. Do we see that? Pretty straightforward. All right. All right. What two monomers would you use to make the polyamide? All right, so you should see again, this is that A, B, B. So that would be one monomer. Now you could have done, I'm gonna draw an ester, but if you would have made an acid chloride, that would have been okay as well. And so you're breaking up on there. Does everybody see that? Let's do another. Do we have any questions on that one? We're good. AJ,
Why the OET?
why what?
Why the OET? Is
It had to be an ester. It could be any ester. You could have said OME or just drawn a methyl group there. right. So again, so this is just that organolithium. So the end cap here would just be a methyl group. Right, so just so that you could see. It's that anionic polymerization. So all you would have to draw here. Well, essentially what I draw on the bottom is what you have to draw, but I'll redraw it. So this is the repeating unit. And then there is your reactive group. Right, then we're adding another monomer. Okay. So the end cap stays the same. It's that methyl group. And then we're going to have another monomer repeating. And a new end group. When you add the epoxide, this is a termination step. This anion, this carb anion is a nucleophile. It's going to attack the epoxide and open up the ring. All right, I'm just going to draw this over here so I have enough room. So you have one repeating unit with the pHs. Come on. We have one repeating unit with the cyano groups. Then you're going to have 2 carbons. 1, 2, and an OH from the epoxide. Do we see that? Do we see how it would terminate that way? So the carb anion opens up the epoxide, the HCl, and the oxygen that I forgot from the water, protonate. What is lithium aluminum hydride? Strong reducing agent. What am I going to reduce here, AJ? Not the OH. The OH already reduced, right? We can reduce aldehydes and ketones or carboxylic acids to OH groups. But what am I going to reduce here? Grace. The CN. Okay. So that you're left with a different polymer. Right. So there is no synthesis on this exam. Right. But we still need to be able to use our reactions. Okay. All right, tomorrow in recitation, I will give you another Robinson annulation, right, with the NMR, right? So there will be 4 of them that you would then have as practice or as reference for this exam on Thursday. Okay. All right, I hope you guys have a good Tuesday. See you tomorrow.